Okay guys, we're going to discuss how to transform our exponential function now that we've learned how to graph a basic one. So we are going to identify each term having something specific to do with our problem. Remember, our b stands for our base, or whatever number that we're taking to the exponential power. All right, h is called the, I can write today real good, horizontal shift. Horizontal means left and right. If I see, this is a big key point here, guys. Oh, I think I did this in green. Yes. If I see, so this would be a hint, maybe write it, star it, something. If I see a plus, we're going to actually shift to the left. We're going to go opposite. Just like with our conic sections, if I saw inside parentheses stuff went opposite, same thing here. If I see a minus, I'm going to go to the right. K is the vertical, or the up and down shift. And we're going to shift the way I see. Which means if I see plus, I'm going to go up, and if I see minus, I'm going to go down. If A is negative, remember he's just a multiplier. Oops, that's not the right color. If A is negative, then the function is reflected or flipped across the x-axis. So for example, we've seen most of them going up this way, or we've seen them going down this way. Now they're going to be completely flipped and going all the way down. So that's what I mean by flipped. I think I'm going to type this next part because I want to discuss some stuff that took a while for them to identify and notice the share. So if A is bigger than 1, meaning that if it's a 2, a 3, a negative 4, it's the whole number itself is just bigger. It represents a vertical stretch. And what does that mean? Well, it's vertical, so it's happening. Oops, wrong one with the highlighter. It's happening to the x's. Verticals up and down. That was stupid. I knew that. I'm having a blonde moment. Please excuse me. I'm having a dumb moment. Blondes are great. You're all smart. I promise. My best friend's blonde. Vertical stretch, which means that it is going to be multiplied to the y values. If it's less than 1 but bigger than 0, it's going to be a vertical shrink. Oops. Which means it's going to be divided. divid to the y values. For some reason that was something shrinking and stretching. For some reason they thought it went to every single piece. Nope, it's just happened to the y's, just those guys. Either it gets bigger, either it gets taller, or it gets smaller. All right, we got 2 parts for questions 1 through 4, I believe there's, yeah. Identify the parent function and then describe the transformation. So what I want to go through is I'm going to go and highlight anything that's changed. And I want to try and do it in the colors that I started off with today to keep everything consistent. So the base will be pink, the multiplier will be yellow, the left and right change will be green, the up and down change will be blue. So that's how I'm going to try and start this off. So I see my base is a 3. There kind of is no change, there's just an x, so I'm going to undo that, only because I want you to recognize that nothing's actually changing. And then I have a +5, so he should go up. So for part A, identify the parent function. Well, that's just 3 to the x. Part B, identify the change. He's going to go up 5. And base is the thing with the exponent. The green is going to be the horizontal change. The yellow is a multiplier, or a divider. In this case, it's a multiplier. So part A, parent function, well, that's 1/4 to the x. Part B, he is going to go opposite. I see -1, so that's actually going to go +1, and plus is going to the right, so he's going right 1. He is also going to stretch, because 2 is bigger, by 2. He's going to be twice as tall. Here's my base. Here's my horizontal. Here's my vertical. Here's my multiplier. Lots of stuff going on to this one. A is 4/3 to the x. Well, we've got a flip. We go, I see +2, so I'm going to actually go left 2. And I'm going to go up 7. Okay, here's the base. Here's the change. Oof, that's a little rough. It's the base. Here's that change. Here's this change. And here's that change. Okay, my parent function is 5 to the x. He is going to be divided by 2. He's going to be shrinking by 1/2. He is going to go to the right 4. And he is going to go down 2. All right, we are going to graph each function and then identify some stuff going on with it. I'm going to see if I can move this slightly since my picture's on the right, or on the left. So we are going to create 2 XY charts. It's a little rough. The first XY will be based on the base, will be used from identifying the parent function, which is why we're going to keep that color there. So 2 to the x. So 2 to the -2nd, so -1st, 0, 1, and 2, and I see my face is in the way, so we got to scroll down a little bit. So 0.25, 0.5, 1, 2, and 4. Then I'm going to identify how this is going to change. Well, I see I have some stuff in the exponent. So I'm going to change it with green, so green is going left and right. So since I am only going to go left and right, my y values are going to stay the same right now. So it's going to be 0.25, 0.5, 1, 2, and 4. So I have to do the opposite of what I see. So currently I see +5. So I'm actually going to take the y value, or I'm going to take the x values, I'm going to say -5. And that's how they're going to change. So -2 minus 5 is -7, -6, -5, -4, and -3. And those are going to be the coordinate points that I graph. Now, just like in our last video, we have our asymptote line. I don't even remember what color that was. We're going to go with red. And he's going to change if I go up and down any. And since I didn't go any up or down any, he's going to stay at y is equal to 0. Now I'm going to plot these points, -7 1/4. Trying to make it a little bit above that line. Yeah, we're going to definitely do this with the mouse. -6 1/2, -5 1, -4 2, and 2. Sorry, I realized I should have switched colors and done that slightly bigger. But the general idea is the same. Then you connect your dots. You don't go lower than the red line. The domain is still all real numbers. Range is y is greater than 0. As my x's grow, I go off towards infinity. As my x's decrease, I go off towards 0. Now I don't see my intercept pop out, so I'm going to show you how to figure that out. Now with my y-intercept, my x value, my x is at 0. So what I'm going to do is I'm essentially going to plug in 0 here. And I have to say, okay, well I have to take 0 plus 5. So 0 plus 5 is 5. So I take 2 to the 5th, which is 32. So my intercept, which I won't see, is 0, 32. All right, we're going to scooch this up and over a little bit. Same general idea. We're going to start by making 2 xy tables. First one, we're going to use -2, -1, 0, 1, and 2. Second one, we're not sure what we're going to do yet. My base is a 1/3, and the -2 is big, so he's going to go down 2. So I need to take my calculator. 1 divided by 3, remember, fractions are just division problems surrounded by parentheses. So the -2nd, which should give me 9. I need a pen. So -1st should be 3. 1.33 and 0.11. In this problem, I don't have any green, so my x's are just going to repeat. This time, however, I have a blue, and blue means the y values, so I'm going to take my y values -2. So 9 minus 2 is 7. 3 minus 2 is 1. 1 minus 2 is -1. 0.33 minus 2 is -1.67. And 0.11 minus 2 is -1.89. Now, something that I want to make a point that I would like you to point out someplace, I might actually go back to the beginning and put it there. I don't have enough room. I might type it then. My asymptote follows my k value. So if I go up 3, my asymptote goes up 3. If I go down 3, my asymptote goes down 3, so on and so forth. So somewhere in there, right about how my asymptote follows the k value, or is the k value. So since my k is a 2, my asymptote, I'm sorry, since my k is a -2, my asymptote is equal to -2. Which is apparent when I see that I can't go past those lines. I'm going to make these slightly larger. So I'm going to plot -2, +7, 5, 6, that doesn't seem right. 1, 2, 3, 4, 5, 6, 7. I go a little cross-eyed looking at a computer screen for all the time I look at a screen. All the amount of times during my day that I look at a screen, so I apologize if I'm like, oh, just count up 7. Well, I kind of go cross-eyed. So -1, 1, 0, -1, 1 down about a little over a half and then a little bit more. And again, since I'm making my dots a little bit bigger, it doesn't look as accurate. And then I'm going to connect my dots as best I can. My domain is going to be all real numbers again. Y is greater than -2. As my x's continue to grow, they go towards -2. As they continue to get smaller, they go off towards infinity. And my intercept is 0, -1. That's not what I wanted to do. Okay, we're going to get out our highlighter and we're going to figure out how this guy's changing. Well, my base is 3. I have a multiplier / divider, and I have an adder. So lots of things are going on. I'm going to start again with my XY charts. -2, -1, 0, 1, and 2. We aren't exactly sure how we're going to change it, so we're going to leave that alone. So I'm going to take 3 to the -2nd, which is 0.11, 3 to the -1st, which is 0.33, 3 to the 0, which is 1, 3 to the 1st is 3, and 3 squared is 9. So I don't have any green, so my y value, I've done this twice now. I don't have any green, so my x values aren't going to change. So we're going to say -2, -1, 0, 1, and 2. However, I have a yellow and a blue. Yellow and blue both happen to y's, so we have to go in order I see it. Yellow comes before blue, so we're going to do this guy first. So I'm going to take my y values, I'm going to divide by 2, hit equals, then I'm going to add 1. So I have 0.11 divided by 2 plus 1 is 1.06. Since I'm starting to run into my graph, I'm going to round. 0.33 divided by 2 plus 1 is 1.6. Oops, I missed another one there. Let me fix that. 1.17. 1 divided by 2 plus 1 is 1.5. 3 divided by 2 plus 1 is 2.5. 2 plus 1 is 5.5. Since I have an asymptote, my y follows and is equal to 1. I'm going to start to plot my dots. We'll do purple this time, so -2, a little bit bigger. -1, just barely any larger. 0's 1.5, so hardly any bigger. 1 is 2.5, so about there, and 2 is 5.5. Oh, I'm going across it. 2, 3, 4, 5.5. It's about there. And then I'm going to go ahead and connect my dots. Range is all real numbers. I'm sorry, domain is all real numbers again. Range y is greater than 2. 1. Definitely 1. My asymptote is 1. I looked at this 2. As x's continue to grow, they go off towards infinity. As they continue to decrease, they go off towards 1. My intercept is 0, 1.5. All right, I'll have to come back. Someone just came in.